Okay, so we're going to solve problem 37 from chapter 9 in the circuit analysis textbook by Robin Millers. So we have this circuit, which was labeled 991, by the way. So this was figure 9-91 in your textbook. Okay, where we had to configure what will be the ultimate value for RL for maximum power transfer. And then B, find the actual max power, and then go ahead and sketch a graph that shows power versus the load, and the load going from 0 to 50 with 5K increment as we plot this. Okay? All right, so the first thing we're going to do is, where we have a couple ways to solve this. We could use Norton or Thevenin. And I'm going to choose Thevenin to solve for RTH and ETH. And the reason is, from the previous video as we've seen, that for the maximum power, you would want RL to be equal to RTH. So we've demonstrated that before. So let's go ahead and find RTH so we can at least state that RL is equal to a certain value. Let's find it. So let's go with A first. Let's start solving for A. So let me just switch to pen here. Okay. So I'm going to draw the circuit for determining RTH. And for that, the rule states, if you're doing Thevenin, so let me just write this here. So if you're doing Thevenin, okay, it is important that you open the current sources and short the voltage sources. So in our case, we have two current sources. Just open them. So what we effectively have is a circuit that looks like this. So this is your 25K here. Here's your 15K. And here's your 20K. And here are the point A and B, and we're looking at the resistance without the load into the system. What is the internal resistance of the system? Now remember, I've opened the current source here, and I've opened the current source right here as well. So now looking at the circuit, what you're seeing are three resistors in series. So RTH is going to be equal to 15 kilo ohm plus 25 kilo ohm plus 20 kilo ohm, and that is equal to 60 kilo ohm. All right. So, okay, well, let's find what is the maximum power. Now that we have this, we know that RL is going to be equal to RTH for that scenario, for max power transfer. Okay, so this is important. Next, let's go ahead and find ETH, because we know that the max power, so P max, if you're using Thevenin, will be equal to E Thevenin square divided by 4 RTH. So it is important that we find ETH. Okay, so for that, let's go ahead and draw an equivalent circuit again. Let's put back our current supplies. And to find ETH is really, what is the voltage VAB as seen through the system without the load? So here's my current source right here of 3 milliamp. And here is my 25K resistor. Here's my 15K resistor here. And do not forget, you still have another network. And let's erase this here. And you have a 20K right here with a current source. Now we could do all of this at once, but I'm going to show you something important here in this for this particular scenario, 5 milliamp. So what we're looking for, let's say we have A and B here, is the voltage VAB, which will be equal to ETH based on this scenario. Notice for Thevenin, remove the load, and you're going to look at the voltage from this point. Now let's think about what's going on here. Okay, so we have A and B open, so there should be no current going through the 15 kilo ohm. So technically, the point A is right here. Okay, well, that's one thing. How about what's going on? What is the voltage drop on this resistor and this resistor? If we're going to look at this loop right here, right? So if we're going to look at this loop right here, right? We can apply Kirchhoff law here. But first of all, what is the current going through the 25K? Well, that current actually is the current from the 3 milliamp. And the current going through the 20K is the current coming in from the 5 milliamp. Now you would say, okay, would they add up here in this portion? No, you have loops here. So all of these loops are self-sufficient, but you have voltage drops here. So let's look at the direction of the voltage. So if a current is coming in this way, so this is positive, negative. So the voltage here, well, let's call it V1, is going this way. So if this is positive, negative, then the voltage V2 will be going in this way. Aha. So the VAB here, so if we had to do Kirchhoff law, right? So VAB will be equal to V1 minus V2. Okay? So VAB will be equal to V1 minus V2. Okay? And you're going to say, okay, well, that's ETH, fine. But what is V1 and what is V2? Like I said before, the 3 milliamp is the one going through the 25K. And the 5 milliamp will be the one going through the 20K. And that is because of this scenario, we do not have a connection between A and B. So there's no current drawn out of these two loops out through the 15K. Okay? All right, so, but if you had to do a node here, all currents on this node here will add up to 0. That will be the Kirchhoff current law. Okay? All right, fantastic. So let's find out what is V1. Well, let me just do VAB is going to be equal to 25K times 3 milliamp. So the K and the milli will cancel out, minus 20 times my 5 milliamp, and again the kilo and the milli will cancel out. Okay, so what does that leave us? So let me pull my calculator. So we've got 75 minus 100, right? So we have 75 minus 100. That leaves us with minus 25 volts. What it's telling us is that, okay, the voltage, right, against VAB, it's in reverse. It's the other way around. All right, so, but we know that ETH will be minus 25 volt if you're looking at it that way, right? Or if you're looking at it from a perspective of, let's say, the equivalent circuit, let's say, then it will be something like this. Here's ETH. Here's RTH. And this is A. And this is B. Now, you could put your load here. RL. Okay. And so now, what you have is 25 volt pointing out down this way. Do you agree? And this would be minus. And that's your RTH. Okay? So now, the key question is, what is the max power, since we're in part B? Well, let's just replace that. So Pmax, right? So we have the formula right here, so we'll just put it in here, is going to be equal to 25 square, right? Regardless, you put minus 25, divided by 4 times RTH, which is 60 kilo ohm. Now remember, this is 10 to the third, All right, so let's find out what that is. So remember that 10 to the third goes up. It will be a 10 to the minus 3. So we have 25 squared, which is 625, divided by 4 times 60, which is 240, 10 to the minus third. And Pmax will be equal to, let's go ahead and do the division, divided by 240, and that would be 2.6 milliwatt. Okay, so there you have it. That would be the maximum power that you will get there. Okay, so now next is to sketch a curve of P versus RL. Well, first of all, what is the power consumed by RL, right? So if you think about it, you have a V load here, right? So in our case, it's going this way, V load, right? Since the current will be going this way, that would be I load, right? So for us, the power at any time against the resistor or the consumed by RL, so let's call it P load, okay, will be equal to VL squared divided by RL. Okay, now you're going to say, okay, well, what is this? What is VL? All right, so if you think about it, you could use voltage divider rule. So let's break it down. We know that VL itself, right? So we know that VL is going to be equal to ETH times RL divided by RL plus RTH, right? So this is a simple voltage drop between A and B, right? So you could use and they're in series, RTH and RL are in series, so you could use the voltage divider rule. So let's substitute that in PL. So PL is going to be equal to ETH times RL, everything divided by RL plus RTH squared divided by RL. And let's see what that leads. So that would be ETH squared times RL divided by RL plus RTH squared. Perfect. So now we've got the equation that we could use to plot. Okay? So you could start putting in the values like RTH and ETH, which are now constants. We know what these are. And we will vary RL. Okay, so you're going to have to put a table together, calculate for each RL with starting at 0 with increments of 5 kilo ohm, go all the way to 50. I would suggest you go beyond 50 so you can watch the curve max out. Okay, so I'll just draw you quickly what it might look like. But first, let me give you an idea what you need to do. So P, so you're going to have ETH squared, which is 625, times RL. So this is what you're going to be working with, divided by RL, and RTH happens to be 60, and make sure you square this. Now, RL is in 10 to the third. This is 10 to the third squared. You're going to end up with 10 to the, so any result you're going to get, make sure it's in milliwatt, because you're going to end up with the 10 to the minus third when you're done. Okay? If I take care of the kilos on the numerator and the denominator, in the end, you're going to end up with a 10 to the minus third. So that's very important. So when you start putting in your values for RL versus P, so you're going to have to tabulate this and go down this way and start with 0, start with 5, start with 10, start with 15, 20, 25, etc. So you're going to calculate what P will be based on these values. What you do is okay, you're going to say 0. You put 0 here and you put 0 here. Well, 0 in the numerator, power is going to be 0. Sure, I mean, that's a short. There's no power to it. There's no load, right? So, but in theory. So, what else? We have 5. Well, you're going to add 5 to 60. That will be 65 square, right? For the denominator. But don't forget to multiply 625 by 5 and then divide by that denominator. So you're going to get some value and some value and some value. Then you can keep going and filling in the table. What you're going to end up with is a graph that looks like this. So you're going to have P and RL. And what's going to happen around 2.6? Now, I've done this before, so 2.7 actually is where it's going to max out. So, I'm sorry. Here you're going to put your resistance. Now, so around 60 kilo ohm, right here, you're going to end up at 2.7 from my calculations that I've done based on P. But, you know, in theory, it's 2.6 right here. What's going to happen is you're going to see something like this. It's going to curve out, max out, and then drop out, right? So this would be the maximum power you will get out of this curve. This is what you will observe as you're filling all of these. So for your case, you're going to have to fill these up, okay? So you can observe this curve as it maxes out at, and this is again P in milliwatts, and this is RL in kilo ohm. So let me just and put this in kilo ohm. So we know what we're looking at. Again, this is in kilo, and this is in milliwatt kilo ohm. Okay? All right, so that's how you would draw it and find out what's going on exactly. Okay? Thank you.